Welcome to Chapter 51, where we're going to talk about animal behavior. Now, in this section, we're going to see that behavior itself, or the science of behavior, is going to be called ethology. And there's two basic groups of behaviors that we'll discuss a bit. The first is innate, which is going to be kind of automatic. It's kind of hardwired in. And then the second will be learned, which is going to be stuff that you are going to pick up from parents, from watching others. These things are not something you could just do by default if I kind of raised you on your own, away from all others. Now, when we're talking about behavior, one of the key things we care about as scientists is causation. Why are you doing this? Now, the two ways this works is the proximate cause is I don't know what I want to say when I say simple one, but certainly the more apparent one, which is how does this happen? So if I go through and I touch the oven or I touch the hot burner, I can tell you that I pull my hand back and I can explain how I pull my hand back. I can talk about the neurons that are being damaged, that are sending the signals for pain up through the peripheral nervous system from the sensory neurons to the interneurons. And if we have a reflex action, it can bypass that initially and come right back down through my motor neurons. It can hit a muscle, cause the muscle contract, pull my arm away. I can describe the anatomy and the physiology that makes that happen. But that doesn't necessarily say why it occurs in the first place. Why did that evolve, if you will, to happen? And that's the ultimate causation. We are talking about individuals that didn't react quickly to something like pain, would have more damage, higher risk of infection. They would not have been able to survive as well as the others that pulled back more quickly. That's the reason it makes sense. So with this, you'll see apples are sweet but also nutritious, so it makes sense that we like the sweet taste, because that, an approximate sense, is just sensory neurons saying sweet is good. But individuals that ate a fair amount of this when it was available typically did well. Now the problem is, at this point, we have a lot of sweets that mimic that, but they're not evolutionarily good for us. They lead more to disease. But they're still piggybacking on the proximate and ultimate causes from before, when we had sporadic access to fruit, and fruits had vitamins and minerals that were good for us. It's just, unfortunately, advertisers and food makers have figured out how to abuse that. Now, supernormal stimulus, this is where many organisms will respond to characteristics even if they are exaggerated, sometimes to the point of ridiculousness. So if I've got something like our three-spine stickleback, this is a little fish that has a red belly. So if it sees anything that has a red belly, it could be like a ball with a red bottom, it attacks. It doesn't seem to be able to detect whether or not it looks like a fish or specifically like a stickleback. It just says red belly, should be a male of my own species, no matter what, I'm going to attack. And we see even in humans that we like, and in some cases even prefer, these overdone, these exaggerations, these caricatures. Whether it's Barbie and the wonderful Barbie dolls that you'll see that don't really reflect actual human anatomical possibilities, or animation, whether it's anime or just regular cartoons, where you see that a lot of them have different numbers of fingers, they can have really large hands or tiny hands, they're got gigantic heads, and overall we like those things. You know, people watch them, people enjoy them. It doesn't seem to mess with us, despite the fact that it's so exaggerated. It doesn't look very close to us. We still seem to recognize it, and in many cases appreciate it. Now, a sign stimulus is something that triggers a fixed action pattern, sometimes called FAP. Now, these are important because once you start this, you will finish this process, this sequence of acts, this sequence of events, no matter what. So if I have an egg, you're going to see a bird will roll that egg. If it's a mother bird sitting on her nest, she will take her neck, kind of pull it in, and she will do that if it looks like an egg. She will do that if she sees the egg, and then you remove the egg. She will keep going. She will not stop, even if the stimulus is gone. That's how you know it's a fixed action pattern. So in this case, the gulls, when they see the mother, they peck at a red spot. That's a fixed action pattern. They'll keep pecking at it. And the mother then is triggered to regurgitate food. So they're going to go through this process. It's going to trigger it, and they're going to finish the process no matter what. Our stickleback friend does the same thing, where once he starts charging, even if you quick pull the guy out, he would still finish his charge and finish his little routine, because it's fixed into him that once he starts, he has to finish. It's kind of like if you jump off of a diving board. you can't stop midway down. You are going to finish the sequence till you hit the water. That's what's going to happen. And so in this case, its organisms are going to keep doing it even if the stimulus is gone. Okay, learning. There's several things that we're going to discuss with learning. The first of all is that learning does change over the development of the organism, over its lifespan. So what you learn, how you learn, is not going to be the same when you're a year old for humans, when you're 5 years old, 10 years old, 30 years old. It will fluctuate because, in our case, our brains are still developing and changing, and we're using different types and amounts of neurotransmitters, and so overall our response will not necessarily be identical when we're a small child versus when we're an adult. And we see this in many other animals, where the way they behave will change over time. There will be juvenile behavior, there will be adult behavior. As a juvenile, they might flee from something, they might choose to hide, they might be aquatic, whereas an adult, they might be eating different sources of food, they might be on land, they might have aggressive postures that they take as they compete for mates and such. They'll behave differently. Habituation is this idea that our brain can kind of get used to stuff, where if a fan's going or the aquariums are going, we can get to the point that it's so consistent that our brain just starts to ignore it. It just kind of pretends it's not there. And then suddenly someone might say something and you realize the TV's on and you haven't noticed it because you were so focused on that book. And then you're like, oh yeah, the TV is going. And then over time, if you sat there long enough, the TV would probably start to fade away again. That's habituation. And imprinting is something you see in many organisms, especially when they're young, where they will in some way lock in on a stimulus. For salmon, this is the chemical makeup of the water. For birds, this is a visual cue that they're going to go into. But during this critical period, usually when they're very young, they're going to latch on to some sensory piece of information, and that could mean that they're just going to follow you around indefinitely. It could be a salmon years later will return to that same spot where it was birthed because it can chemically detect where it was birthed. But one way or another, that information gets locked in for at least a period of time. Sometimes you'll kind of grow out of that imprinting, but at least for a period of time, it's going to be locked in information. And then lastly for this one, when you want to try to associate different things for learning, when I want to connect different stimuli, there's two ways we can discuss doing this. The first was the one that you saw by Pavlov, and that's classical conditioning, where he would just go through and feed the animals, and he noticed eventually that they were anticipating the feeding, and they'd start salivating into these tubes he rigged up to their salivary glands ahead of time. So then he said, well, what if I use another stimulus right before I feed them? And he was able to get them to link feeding to a metronome, bells, you name it, music, TV, as long as he just played that thing consistently before he fed them. So soon the dog would just hear music and think, okay, I'm fed right after there's music, start salivating like crazy, even though it hadn't gotten the food yet. Now with operant conditioning, we're not just kind of linking to based upon like a time frame, like the fact that they happen to kind of coexist generally, so you realize when one happens, the other soon follows. In this case, it's trial and error. It's typically rewarding or punishing someone based upon what they do. So, for instance, school works a lot like this, where if you do something that we think is good, we reward you with points. If we think you did something that was bad, we take points away, or perhaps punish you with like detention. And so by doing this, our goal is, if I keep saying every right answer, I'll give you a candy or $1. The goal then is that you keep going, well, I want money, I want candy, and so you keep giving the right answers. The other option I can take, if I'm kind of more of a jerk, is I could say every time you give me a right answer, I don't cattle prod you. Every time you give me the wrong answer, I do cattle prod you. And so after you get cattle prodded a couple times, you probably won't want to continue to be cattle prodded. And so you'll start to try to do the proper behaviors. So this wraps up chapter 51 and also explains why teachers should be giving cattle prods.